B.2, role of data structures. Let's look at new topic related to the data structures in our algorithm design. All right. Problem number 2, search an unordered array. So look at the simple problem, very simple. First, given an unordered array, I think the index should be n-1. All right, from 0 to n-1. So the total size is n. All right. And also we are given a search key. All right. The goal, we need to find index I such that k equals a of I. That's simple, straightforward. So I believe you can do it easily. Yeah, but here, so we try to learn something basic here. All right. Problem type. So the type of problem, the search type. Yeah. So that's our basic type. We have search, sort, selection. These 3 basic types for our algorithms. Yeah. So this is the search type. Yeah. Data structure. All right. So this is a commonly used data structure and the simplest. Yeah. We are familiar with array. Yeah. Later, we will learn more and more advanced data structures. The reference I give you here, so you can read section, page in our textbook. All right. So why the data structures are important? Yeah. At this point, you may not have good understanding for this question. Here, let me give you the answer, but we will spend a lot of time trying to understand this answer. The answer is, through data structure, we can make our data well organized. So the purpose is to organize our data in a special structure. Why we do that? If the data is very messy, think about if your data is very messy, when you process it, you are very likely to spend much more time. If your data is well organized, then it can save you a lot of time. So that's the, basic reason behind it. Okay. All right. So that our algorithms can take advantage of the special structures. Yeah. Because those structures we carefully design to make it, as a good fit for our algorithm. So, all right. Yeah. We have to, that's why I said we need to use many examples to see this point. Yeah. And the goal, get better performance. Yeah. We will quickly see such examples. Yeah. All right, analysis. First, actually, let's solve the problem, then we do analysis. So we do together, okay? So let's do the work and analysis here, okay? All right. The basic operation we use here, comparison, okay? And when we do comparison, we know the result we can predict easily, equal, not equal. If not equal, greater than, less than. Yeah. So that's simple. All right. Compare our key K with any element in the array. Yeah. So we scan our array from beginning to end. We start from the first element. So our initial value of index I equals 0. And now let's consider the general case for the comparison. Two possibilities. K equals the current element. So here, this is our current element. K equals the current element, right? The first case. K not equal to the current element. Not equal. So we don't care greater or less, just not equal. Okay. For the first case, then we find the key, we find the location of the element that matches the given key. Our algorithm returns the index value I, and the program terminates. That's simple. The second case, we miss it, no match for the current element, then we do iterations. Go to the next iteration. But for the next iteration, we compare K with the next element in the array. Okay, so then we go back to the same situation like that. Okay, all right. Now, the end of the scan. The end of the scan. Eventually, we may need to reach the end of the array, right? So when you reach the end of the array, now you need to consider, okay, can you get, because when you reach the end of the array, your I equals n minus 1. So that's why I like to change this as n minus 1. I'll fix it. When I hits the last index n minus 1, but you still get a miss, K not equal to that last element, the value of the last element. Now, what you return? -1. Because -1 does not correspond to any index, any valid index value. So this is used as a flag that tells us the key cannot be found in the array. So that's the information we need. And the program terminates. So here you can see, no matter what case you will have, the program always terminates. Okay. All right. Now, let's look at this algorithm. Its name is Sequential Search. Another name, Linear Search. So we can use either one. All right. Now the question, how do we measure its performance? Now we find a solution, but we don't know how good is the solution, right? We don't know that. So we need to do some analysis to find it. So let's do that. How do we measure its performance? So now we need to look at this question, important question, and a basic question. All right. To answer that question, we need to do this. Count the number of comparisons. So let's do that counting. Here, let me do this chart again. So you can see in this chart, we scan from the beginning to end, right? There are several possibilities. The first possibility, the first element equals K. Then the number of comparisons we need, 1. Second case, the second element equals K. Then the number of comparisons we use 2, and so on. Until, if we compare the last element we get a match the number of comparisons, n. Yeah, all right, so here still n minus 1, okay? Yeah. All right. But after that, there is another case, no match case. The key, the given key, does not appear in the array, no match case. In that case, we still need to use n comparisons, but we fail all those n comparisons. We get a failure. So that's all the possibilities for this problem. All right. We can see the first one corresponds to the best case. So we are very lucky when we do the first comparison, we find it. So that's the best case. Yeah. What's the worst case? Yeah. The last two cases, that's the worst case. They use the same number of comparisons, n. So they both corresponds to the worst case. All right. Now, let's look at our question. How to measure the overall efficiency. So now I add this. Yeah. Because when we talk about the efficiency, so here, the word, here we use efficiency, and sometimes we also use performance, the same thing. Okay? Yeah. Performance, efficiency, we mean the same thing, different words. Yeah. Overall efficiency, overall performance. So that is that number, performance number, efficiency number, should reflect the overall efficiency. Yeah, not just the best one, not just the worst one. It should be, give us overall. Yeah, you know that, right? Yeah. Not the best case, not the worst case. Then we can pretty much figure out what's the meaning of it. Okay. The measure should include all the cases. Yeah. All the cases. We need to factor in all the cases. Yeah. But the question is, how do we know all the cases? Right? How do you know it? Yeah. So for this particular problem, to solve this particular problem, we need to make some assumptions. We need to make some reasonable assumptions. In our problem 1, we made some assumptions, right? The unit time, addition, multiplications, right? Yeah, we made assumptions. Here, we also need to make assumptions. Yeah, so let's do it. All right, so for our data, for all these cases, let's make reasonable assumptions. Yeah. The first one, we can assume for the first n cases, each case in this part has the same probability. Yeah. So each one same probability. That's reasonable, right? Because we have no reason to favor any of the cases. So that's why we assume equal opportunity here. Okay? Unless you have some reason to favor, some of them. Yeah. Otherwise, if no information given, so we assume the same probabilities. Yeah. All right. Now let's use this probability number to represent, the chance, right? The chance for each case. Yeah. There are 2 cases. The first, index case. Yeah. Index case means our program returns a valid index from 0 to n minus 1, any of the number between them, that is a valid index. So we call it index case. The last one, no match, because we return -1. So here we just call the -1 case. All right. Now we assume the probability for the index case. That means we put all index case together, all possibilities of index case together. That's the P. That is a number P. The probability P should be between 0 and 1. 0 and 1. Probably precisely, I may like to put equal. All right. Yeah. Extremo, we add 2 extremo cases. Yeah. 0 also okay. 1 also okay. Yeah. Extremo cases. Let's add it into the consideration. Yeah. Then the complementary part. Yeah, because the -1 case, that's the complementary case situation for the first case. Yeah. 1 minus P. Yeah. All right. So now with this, we can do analysis under these 2 assumptions. So we need to get that overall efficiency number. Yeah. But we leave that to our next video. Part B.3. Analysis for average efficiency. All right, so let me stop here. Yeah.